over the challenge question from this lesson. This one's pretty intense, so if you got it, you should feel incredibly proud. But if not, no big deal, because this is a pretty tricky problem. So it says breathing air that contains 4% by volume of carbon dioxide will cause rapid breathing, throbbing headache, nausea, other symptoms. What's the concentration of CO2 in that air in terms of molarity, right? Assuming 1 atmosphere of pressure and a body temperature of 37 degrees. Okay, so this one's pretty tricky, so follow me here. It didn't tell us how much air we had. So let's assume there's 1 liter of air outside of our body. And outside our body, it's standard temperature and pressure. Okay, in that 1 liter of air, if it's 4% carbon dioxide by volume, that means we have zero point zero 0.04 liters of carbon dioxide because 4% of 1 is zero point zero 0.04. Okay, you can plug in a calculator, but you should be able to see that relationship there. So if we have zero point 0.4 liters of carbon dioxide, and if you remember, at STP, 1 mole of a gas takes up 22.4 liters, I can figure out how many moles of carbon dioxide I have in 0.04 liters. So I do this simple equation, ends up being 0.04 divided by 22.4. So in that 1 liter of air, I have 179 moles of carbon dioxide. Now, that's in 1 liter, right? So if we want a molarity, right, we can just do moles per liter, and that should be the molarity. However, when you take that liter of air into your lungs, the temperature changes, and therefore the volume of the gas changes, right? So if we remember this equation, okay, and notice there's no P because pressure is constant here. That 1 liter outside your body, this is standard temperature, right? This allows us to come up with this calculation, right? Remember, this is only true. 1 mole of a gas takes up 22.4 liters. This is only true at standard temperature and pressure, okay? So we calculate the number of moles outside our body. And remember, that's a number of particles. So when we inhale that liter, we have the same number of particles, but the volume of the gas will change. Because in our body, and notice I'm using Kelvin for temperature, right? Because otherwise this would be 0, and you can't divide by 0. When we inhale, the temperature of the gas changes to 310 Kelvin. I got that by adding 273 to, like our problem said, was a body temperature of 37. So that gives us 310 degrees Kelvin inside of our lungs, which means the air we just took in expands and actually has a volume of 1.14 liters. All right, so really we have, when it's in our lungs, okay, we have 0.00179 moles of carbon dioxide, and the whole gas is taking up 1.14 liters, which means the concentration when it's in our lungs, okay, molarity is moles divided by liter. There's our moles, there's our liter inside our lungs. Notice how moles doesn't change because that's number of particles, right? So we do this division, we get 0.0016 moles per liter of carbon dioxide. Okay. Now the answer would have been 0.00179 moles per liter outside our body, but once we inhale the carbon dioxide, the gas actually expands and it's less concentrated, right? Because now the volume increased, but we have the same amount of particles, so it's actually less concentrated in our lungs than it would be outside of our lungs because our lungs are warmer, which causes the gas to expand. All right, that's a pretty tricky problem. If you got it, I'm impressed. If not, don't feel bad. That's a tricky one, right? It involves a lot, but it's a good review of gas laws, right? Little gas laws in there. Okay. All right. So again, that was totally optional. Never going to ask you a question like that on a test, so don't worry about that. All right.